Today we'll discuss delta to star transformation and star to delta transformations. First, we'll write a diagram for delta circuit. So we can write a delta circuit like this. This is we can call as RA, and this is we can call as a RB, and this is RC. So inside you can write it this in star circuit. R1, and this is R2, and this is R3. We can label this node as a 1. This is a node 1, and this is node is 2, this terminal, and this terminal we can call as a 3. So that means here RA, RB, RC are connected in delta. That should convert it into the form of R1, R2, R3 connected in a star. Consider this terminal 1 and 2, and looking from this terminal, write a circuit diagram. Looking from the 1 and 2, we can write a circuit like this. This is your RB, this is the terminal 1 and 2, this is our RB, and RA and RC are connected in series because we are looking from the terminal 1 and 2, and this node is not connected anyway, therefore RA and RC are connected in series. This is RA and RC, they are connected in series. Looking from this terminal 1 and 2, the total resistance is given by R12 is equal to RB, and RA plus RC are connected in series in parallel with the RB. Therefore, we can write it as RB into RA plus RC divided by RA plus RB plus RC. So, call this equation as a 1. Now consider the same two terminals for the equivalent circuit of the star connection shown in this diagram R1, R2, R3. Now looking from the same terminal 1 and 2, what is the equivalent circuit? So looking from the 1 and 2 for the star network, so we can write a diagram like this. This is the terminal 1 and 2, and this is the resistance is R1, and this is the resistance is R2. And no R3 is not connected anywhere, therefore we can neglect the R3 resistance, and R1, R2 are connected in series. Therefore, looking from the terminals 1 and 2, the total resistance is given by R12 is equal to R1 plus R2. So call this equation as a 2. So equate 1 and 2. From the equation 1 and 2, from the equations 1 and 2, we can write it as R1 plus R2 is equal to RB into RA plus RC, RA plus RC divided by RA plus RB plus RC. Call this equation as a 3. That means here, see here, R1, R2, R1 plus R2 is equal to, you have to remember like this, RB into RA plus RC divided by RA plus RB plus RC. Similarly, R2 plus R3 is equal to this RC into RA plus RB divided by RA plus RB plus RC. R3 plus R1 is equal to RA into RB plus RC divided by RA plus RB plus RC. So similarly, we can write a diagram like this. So similarly, we can write like this, R2 plus R3 is equal to RC into RA plus RB divided by RA plus RB plus RC. Call this equation as a 4. And R3 plus R1 is equal to RA into RB plus RC divided by RA plus RB plus RC. Call this equation as a 5. Subtract the equation 3 minus 4. It gives R1 minus R3 is equal to RA RB plus RB RC minus RA RC minus RB RC divided by RA plus RB plus RC. Here RB R will cancel here. So then you'll get here RB minus RC divided by RA plus RB plus RC. So call this equation as a 6. Now add the equation 5 and 6. Adding the equation 5 and 6, we get so here R3 if they cancel, they'll get a 2R1 is equal to RA RB plus RA RC plus RA RB minus RA RC divided by RA plus RB plus RC. So that is equal to, here RA RC will cancel, this will cancel, then we can write it as 2 into RA RB divided by RA plus RB plus RC. So 2 will cancel, then we can write it as R1 is equal to RA RB divided by RA plus RB plus RC. Call this equation as a 7. Similarly, you can write it for R2. R2 is equal to RB RC RA plus RB plus RC. Call this equation as a 8. And then R3 is equal to RA RC divided by RA plus RB plus RC. Call this equation as a 9. RA and B, RC are connected in delta. We are converted in the form of R1 and R2, R3. R1 and R3 are connected as in star. That means we are converted delta network into star network. Next, you have to consider, that means you have to convert star to delta or T to phi transformation. Now we have to do convert star to delta, or we can call it as a T to phi transformation. To convert this, you have to multiply the equation. Multiplying the equations 7 by 8, 8 by 9, 9 by 7. So we get an expression like this: R1 R2 is equal to RA RB square into RC divided by RA plus RB plus RC whole square. Call this equation as a 10. Next, R2 and then R3 is given by RA, RB, RC square divided by RA plus RB plus RC whole square. Call this equation as a 11. R1 R3 is equal to RA square RB RC divided by RA plus RB plus RC whole square. Call this equation as a 12. Now add all the equations. That means you have to add equation 10, equation 11 and 12. After adding, you will get an expression like this: R1 R2 plus R2 R3 plus R3 R1 is equal to RA RB square RC plus RA RB RC square plus RA square RB RC divided by RA plus RB plus RC whole square. If further you can simplify, here you can take the common factor as a RA, RB and then RC. Then you will get RB plus RC plus RA. So divided by RA plus RB plus RC square. So this will cancel. So you will get RB RC divided by RA plus RB plus RC. Call this equation as a 13. Okay, this is our R1 R2 plus R2 R3 plus R3 R1. But from equation 7, what is R1? R1 is equal to RA RB divided by RA plus RB plus RC. So that means here this we can replace this RA RB RC. This we can replace as R1 R2 plus R2 R3 plus R3 R1 is equal to, we can write it as R1 into RC. Okay, so therefore we want to find out what is the RC value. That is, RC is equal to R1 R2 plus R2 R3 plus R3 R1 divided by R1. So divided by R1. This is the RC value. So similarly, you can write it for RB value. Similarly, you write it for RB. RB is equal to R1 R2 plus R2 R3 plus R3 R1 divided by R3. Then RA equals R1 R2 plus R2 R3 plus R3 R1 divided by R2. So now we are converted R1 and R2 are connected in a star, that we converted in the form of RA, RB and RC, and this RA, RB, RC are connected in delta. Now we'll solve the problems. First we'll solve the simple problem. Replace the star system shown in figure by an equivalent delta system. So they're given the star network like this. This is a star network. This you have to convert it to delta network. Delta network. That means you have to convert this into delta network like this. That means you have to convert like this. Delta network. This is a delta. You can label this as RA and this is RB and this is RC. You have to find out what is a RA, RB and RC value. So what is the RA value? So RA is equal to this 4 into 6 plus 6 into 10 plus 10 into 4 divided by RA opposite is 10. You have to remember like this 4 into 6 plus 6 into 10 plus 10 into 4 divided by 10. That gives RA value is 12.4 ohm. So next it is RB value. RB value is numerator is same 4 into 6 plus 6 into 10 plus 10 into 4 divided by that RB opposite is 6. So that is 6. That gives your 20.66 ohm. 20.66 ohm. Similarly, RC is equal to numerator same 4 into 6 plus 6 into 10 plus 10 into 4 divided by what is RC opposite is the 4. This gives your 31 ohm. We'll solve another problem. Replace the delta network by an equivalent star network. This is your the delta network. This is the delta circuit. Okay, this you have to convert it into star. This is the value will be 10 ohm and this value will be 30 ohm and this value will be 20 ohm. This you have to convert it into star network. This you have to convert into star. So like this you have to convert this network. You have to find out what is the R1 value and what is the R2 value and then what is the R3 value. What is the R1 value? According to the derivation, R1 is equal to 10 into 30 divided by 10 plus 20 plus 30. You have to remember like the R1 is equal to 10 into 30 divided by sum of this 10 plus 20 plus 30. That gives you 5 ohm. 5 ohm. Then R2 is equal to 30 into 20 divided by 10 plus 20 plus 30. That gives your 3.33 ohm. Similarly, find out what is the R3 value. R3 is equal to 10 into 20 divided by 10 plus 20 plus 30. After simplifications, we get a 10 ohm. Next is solve one more problem. Determine the input resistance that is Rin using star delta transformation in the network shown in figure. So this is the diagram. So this is the diagram they give. and this is the point is this, and this is the input resistance R in. You have to find out this input resistance. The values are 5 ohm, and this is your 6 ohm, and this is 6 ohm, and this is 18 ohm, and this is also 6 ohm, and this is 18 ohm, and this is 6 ohm. So looking from the diagram, this 18 ohm and 6 ohm are connected in series. This diagram we can write like this. This is our 5 ohm, and these are the node here. This is the node, and this is the node, and this is the node. This we can write like this. The same circuit we can write like this. That is, this from here to here, this is the resistance. That value will be 6 ohm. From here to here, this we can write like this, and this is will be 6 ohm. From this node, we can write like this. We can write a diagram like this. These are the node. These are the node. This is 6 ohm, 6 ohm, and this is the 18 ohm. The same circuit I written according to my convenient to apply the delta to star network. I have not changed the circuit by I written according to my convenient. Here from this to this node 6 ohm, again I written from this to this node 6 ohm only, from here to here node 6 ohm only, and then from this to this node 18 ohm only. Same values I written. Again here this is another, it is a 6 ohm, and from here to here resistance is, this is your 18 ohm plus 6 ohm are connected in series. Therefore this becomes here 24 ohm, and this is the input resistance R in. And okay, now convert this 6 ohm, 18 ohm, and 6 ohm are connected in delta. That you have to convert it into star network. That means you have to convert it into this is to star network. This has to convert it to star. That means you have to convert what is the R1 and what is the R2 value, and then R3 value you have to calculate. So according to formula, what is the R1 value? R1 is equal to 6 into 18 divided by 6 plus 6 plus 18, that is equal to 3.6 ohm. And then R2 is equal to 6 into 6 divided by 6 plus 6 plus 18, that gives 1.2 ohm. And then this is R3 value is equal to 18 into 6 divided by 6 plus 6 plus 18, that gives here 3.6 ohm. After converting delta to star network, the original circuit we can write like this. So this is your 5 ohm, and whatever the delta circuit that we are converted, and this is the R1 value, and it is, this is like this we can write, and this we can write. This is your 1.2 ohm, and this is your 3.6 ohm, and the remaining resistance as right as it is. And this is your node, and here written as a 24 ohm, that you are right. This is the resistance is 24 ohm, that right as it is. This is the input resistance you have to find out from this terminal. Again, we further simplify this. 5 ohm and 3.6 ohm are connected in series. Therefore, this becomes a 8.6 ohm, and this is the node here, and this 1.2 ohm, and this is actually the previous in the circuit. This is a 6 ohm and 1.2 ohm. They are connected in series. Therefore, this becomes your 7.2 ohm, and here this resistance 3.6 and 24 are connected in series, this value will be 27.6 ohm, and these are connected in parallel. So these are the node, and this is where from this point again you have to calculate what is the input resistance. Now what is the input resistance? Now Rn is equal to 8.6 plus these are connected in parallel, therefore parallel 7.2 into 27.6 divided by 7.2 plus 27.6. We already familiar when they are connected in parallel, the total resistance is given by R1 R2 divided by R1 plus R2. Again that will comes with the circuit 8.6, and 8.6 this resistance will be connected in series, therefore we are adding that value. Then after adding we'll get an input resistance, it will be 14.31 ohm.